So you know how to implement the depth-first traversal algorithm using recursion, but we can also implement this using iteration, and that's pretty interesting. Now, before I show you how we can do that, let me explain how the Java runtime executes a method. So let's say we call method A with X. When the Java runtime starts executing this method, it's going to grab the X and push it onto a stack. When the method A finishes execution, the Java runtime is going to remove the X from the stack. Now, what is the point of this? The purpose of this is to remember the value of the arguments in between method calls. So let's say in the middle of method A, we have a call to method B with Y. So when the Java runtime starts executing the method A, it's going to push the X onto our stack. Now, before it can remove the X, we have a call to the method B. So here, once again, the Java runtime is going to push the Y onto our stack. When the method B finishes execution, the Java runtime is going to remove the Y from the stack. Now, it remembers the value of the X prior to the call to the method B. So here we can print the X and see its value prior to the call to the method B. This is the reason why we have this stack over here. And by the way, this stack is called the call stack. It remembers the value of the arguments in between method calls. Now, we can use a similar technique to implement our traversal algorithm using iteration. So, initially we want to validate our root node. We want to make sure this is a valid node in our graph. Then, we're going to push this root node onto our stack. Now, while the stack is not empty, we're going to pop it and store the result into a variable called current. Now, what should we do every time we reach a node? Well, we should visit it, which means we should print it on a terminal, and then we should visit all its unvisited neighbors. So we're going to do the same thing over here. We visit the current, and then we're going to push each unvisited neighbor onto the stack. Now we go back to the beginning of our while loop. So this process will continue as long as the stack is not empty. Okay? So go ahead and spend 10 minutes on this exercise, then come back see my solution.